friends, this is Tejas from TJ Edu for Innovation. And in the previous classes, previous session, we discussed about what is PCB and the types of technologies, that is through hole and SMT. And we took example of pictorial representations, how it will be looking in the through hole and SMT part. Major types of boards, that is single, double, and a multi-layer board, and types of vias, that is through hole via, blind via, and buried via, and a formation of a multi-layer board. So these are the basic things we discussed in the previous session. So now we will move on to a schematic design of a PCB with a basic example. For designing a schematic circuit, we need a platform called an ID, Integrated Development Environment, that is a EDA tool. So that is called as a, we are using like kicad. So that is a very widely used tool over the PCB manufacturing sectors. So we are using a kicad as a tool IDE for the development of schematic and layout representation. Kicad, in that we are using a old stable, that is you can go to the websites of home website of kicad, and there you can download the old stable. After installation you can start designing with the PCB or desired customized combo circuits. So let's move on to the circuit designing. uh, for that we need to go for some basic part of learnings. So there is what's the how to prepare the schematic and how to make that. So this is a KiCad IDE, Integrated Development Environment for schematic and layout designing of a PCB. So let's open this one. So initially we will have a window like this one. So similar to other IDEs, go to File, and you have to create a new project. For that select a blank. Okay, then go to my documents or select any desired drives or somewhere, create a new folder for your project. I will go to PCB projects, so I'll give this a folder, and select this folder. Okay, next is you have to start giving with the, after selecting that, just give the file name, like I will give it the test, I will give it the test 1. Okay, okay, this is a directory where all your schematic and layouts and schematic to layout components files, all this will be saved under this. And for initially we have, for the schematic design, go to the schematic editor, and you will get a window with a sheet of drawing sheet, where you can write your schematic circuit. Schematic is nothing but a similar circuit how you write in a book or lab manuals, like how you write a simple circuit. Similarly we are writing that schematic circuit over this sheet. For that you need a, I can change the background color if you want. Go to colors, prefaces, colors, then change to background color. I would like to work on white, so I will select with the white, apply. So the background is changed. So, and it is having a components, for each placement components will be placed under a grid reference. Okay, this is a grid, and if you want to have the visibility of grid over this schematic circuit designing doesn't matters anything. But if you went to, when we're going to layout part, the grid plays a very wide role in that, while placing the components, or if you want to make some customized footprints there, the grid is very helpful to that. So just to we'll go on now we'll go on to the schematic circuit designing. For initially to design the schematic circuit, you need some components which are the, so we will start with a very basic LED circuit, like a battery and a resistor and a LED, with the three components, and so that you will get more familiar with how to use the components and how to make the connection with small examples. So let us for the components, you need to go for components, place a component. This is the option, just click it and open, list all. So you'll have the all components out there. And I need a resistor, LED, and most common circuits components which we use in the circuit, that will be available in the under the category of devices. So just click on it, so you'll have the all components out there. These are the most components we commonly used over the circuits. So like battery, capacitor, resistors, and LEDs, all common, whatever the components out there, that will be available here the under the device filter. Okay, so select on battery. We need a battery, place it. Again, go to components. We need a like a resistor, device, go to and take a resistor. Okay, we need a LED, device. Okay, give it the LED. Okay, just want to make some components to alignment or place the component in a very good manner, or to represent the circuit very looking very actual form of a circuit, instead of drawing a tracks in the crossway or like that. So we'll place components. For that we have a lot of shortcut keys will be you can use. That shortcut keys, to know the shortcut keys, just to place, hold the shift and click on question mark, so that you will get the list of shortcut keys that you can use over the while using PCB designing, so that you can work faster. So I'm very familiar by practicing, lot of practice. So for movements, we place the cursor over the component which you want to move and click on M. This will stick on to the cursor, the component will be stick on to the cursor, and you can start placing anywhere you want. And if you want to rotate this, just to make like rotation, use R. Okay, so use R, so that you can rotate the component and place it. Again, for resistor also, so just to move that. Okay, then done. So let us move this, rotate. Okay, done. Now the part is drawing the tracks, that is making the connection between the terminals. So for that you can use a place a wire. Click on that and start writing the wires across each terminals. Okay, done. Okay, then after this you need to annotate the components, whatever the changes you have done with the components. And also you can change the reference values of the register. Every component has to our references. This is the design just to have the reference of component values. So when it is added to schema like silk screen, so that during the completion of PCB we'll get to know which component values has to be placed there. This helps a lot when a very complex circuit is there, and more components are there over a PCB. So just we'll for that editing the name of the register, so you can use E. Just place the cursor, click on, place the cursor, and click on E, so that it will start editing. So for editing you just use we'll give like 1 kilo of home. Okay, let's give that okay, just give to that. Okay, next is you can also give the LED color which you want. If you decide, just give a edit and give like red. Okay, done. Next is edit, we'll give like 9 volt of value, 9 volt of battery it is. Okay, these are all done. Now you have to annotate that you have changed the various names of these components, all things. So just to that you make a annotation. Okay, annotate only unconnected components on the entire schematic. The operation will change the current and cannot be undone. Okay, uh, nothing to change here, just annotation. Okay, done. Okay, this is all done, annotation is done. Now you can start checking for errors, if there are any errors here. No, there is no errors, there is no unconnected open circuit is not there, so that you can start generating a netlist. So netlist is, once you created the netlist, so this will list all these components to the a CVPCB listing, that is where the schematic to modules it will be added. So for that you can see check out now, click on it. So this netlist will created, and for this each components we should add a certain modules to this. For that you can there are three kind of filters to sort the modules. For that you can use either a by name reference, or by number of terminals, or by a complete list. So I will sort by name, so that it will help a lot. So register, take a register, and if you want to have the vision, so that you can view here. So this is the module representation for that resistors. Okay, you can use this resistor. Battery is the external connector, as to is placed in external, so you can use a banana connector, or a pin array pin connectors. Oh, here it is, pin array 2x2 1, you can use this one. And LED, we will use 3 mm of LED, and you can have the vision too. So this is the size of a 3 mm LED footprint. Okay, all components are schematic to modules is added. Just make it to save, close this. And next is we are this is about all about the schematic. This connections whatever is there, this can also be built using naming the naming like similar name, using the similar naming for the wires, you can use that. So for that just make another example I will give. Okay, just draw like wires to this, a just make a representing of wires like this, just like this, make this. Okay, done. Next is start naming the each one. Edit. Okay, just place it. Oh, like I will give a TL1 like this. Okay, you can place like this again. uh, take a similar name, TL1. Okay, this will start connecting the components. This line will be connected, you need not to make connections with that. So this will, whenever you draw a very complex circuit, you doing with a very complex circuit, during that time you need to mention like this names, because this will, if you draw a very long, normally with a large number of wires together, so that will make a more complexity analysis. You cannot very makes very complexity to analysis over the circuit. In order to overcome that, for that you can use this technique. And again use like TL0. Okay, uh, just make sure you are placing the properly the name values to this wires. Again TL0. Okay, just placed it. Okay, next to this or connected, now we will place this TL2, make it like that. So you can use anything, so the same name has to be used in the where it has to connect the components, TL2. Okay, done. Need not to re-annotate, it's okay, we can annotate that. After that check for the, see, no errors. Okay, next is check for netlist, it's already there, no need to, so no error system. This is how you can build without a wire in the schematic. Like this, this is just a basic example. In the next session we'll discuss how to represent the layout for this schematic circuit, and this is all about the schematic designing about in a PCB. And we will discuss in the future, we will discuss like various topics on adding library components and many of the aspects. And this will be helping lot over a manufacturing. We'll teach you until the manufacturing file is how to submit to the manufacturing sector. In that manner we'll train you under. So this is a very basic example of a schematic designing in a kicad IDE. And once again, thank you to all. uh, Meet you soon, and we'll continue with the session in the second next upcoming sessions. In the upcoming session, as I told, we'll discuss about the uh, layout part of design.